So in this video, I'm going to explain how you can get worms like explosions. If you've ever played the game Worms, the explosions are perfect circles and they look somewhat like this. This thing runs incredibly quickly. This is using my scroll wheel and it is going incredibly quickly. It can do way more explosions than it would ever need, which is perfect. Worms never really needs this many explosions, but you got this. I'm not going to get into how the levels are generated in this video. Maybe it'll be a separate video if anybody's interested. But fundamentally, it's a PNG. I have a couple options here, but this is the PNG it's using. And it uses some mass. But I want to get into this video is purely about the explosions. You can check the GitHub and look at explosion.py to really look at the code and see exactly what it's doing if you're interested in that in particular. I have full documentation here, all these comments to try to explain what it's doing to the best of my ability. So on init, we do set rect using the radius and an x and a y. Now, this is the circle, right? This center position is the x and y. X and y is the center position, and you can see in set rect, we are setting it to 0, 0. Which is this point right here, and we're getting the radius, which is this point, and this point. Or kind of. It basically just gets these 2 points, and that will generate a rect of this area here, this whole area. Then, what we do is we set the center to be that x and y position, which will actually move the rect to be in the position that we want it to be, which is where the center... It'll be central to the mouse, and you can see this, and when we run it, you can see that when you click, our mouse is in the center of that circle, which is what you want, and that's what this is doing. So this is where it sets the sprite here. It sets sprite, and this is set sprite. It's the same image every time. It's a circle. I have an image just because I'm too lazy to make a whole surface and draw a circle to it. It's easier just to have a picture of a circle in the files that you then pull from and then just create a mask with that image. It's just easier that way. And then scales the image using the radius. Scale uses a size, which is an x and a y. Kind of an x and a y. It uses an x and a y, and you pass in the radius, which is giving it. In these specific cases, in the main when I'm running it, it's doing 80 by 80. Because the radius is also only going out half, and you want a full 80 by 80. Yeah, that's basically it. This is where it stores the sprite in a variable that it is contained within the object, and then we do set mask. Set mask takes this sprite here and generates a mask from that surface. And then it creates a draw mask, which is used for this draw function down here, which you'll see where it gets used later. But that's where it gets used, this draw mask here. But basically, it just draws the mask to a surface and sets the unset, which is just, in this situation, just a transparent to transparent, and sets the color to white, where it is. So yeah. So then we're going to go down to explode, which gets called right here for each explosion, which this is where the explosion gets made. It removes an explosion if it can, which I don't actually need to do the try anymore because it's working differently than I had it working previously. But it just does this explode function. It passes in the level and the screen. So it needs level. Because it needs to get it needs access to that PNG, but it also needs screen in order to draw itself to the screen, which you can see right here is where it does this function where it draws itself. It updates it so that you can see it flash. If it didn't do that, you wouldn't even see it be drawn, because other stuff would get drawn on top of it after the fact. Actually, it wouldn't matter, but it's still good to have because I might draw stuff. It's there for now. I might remove it. You'll see in the GitHub if you look at the GitHub where all this code will be. Then you have overlaps. Generating overlap returns a list of overlaps, and basically it takes the mask of the level. And the reason it's mask and multiple mask is because look at this image here. Look at the worm level. You can see that there's a hand here. You can see that there's the worm himself, this grenade, and this. Pygame when it makes the mask, it actually creates separate masks for each of these objects. Each of these have their own separate mask that work in their own way. And you can see that getting the mask here for the foreground, mask equals the connected components. I actually don't need these bounding racks, but maybe they'll be gone by the time you look at the GitHub. Maybe this thing will be fully done by the time you look at the GitHub. I don't know. It's going to be... I'm hoping to make all of Worms in Pygame. We'll see about it, but all of it will be on GitHub as it comes out, as I do work on it. Anyway, it gets the mask of the level. It creates an empty list for just storing each of these overlaps, since it's going to append them to there. Now we're going to iterate over the mask, the level parts, the level part mask, using a for loop with indexes. Just I think, actually in this situation I could just switch it to be for blank and blank. I actually don't need it to be a for loop like this anymore. These are just things I'm realizing as I'm looking at it now. Then it sets this because it's just doing level part anyways, and we're not getting, there's no like rec stored separately. It creates an empty, but anyway, it gets a level part. It creates an empty surface with that is the width and height of the screen. This thing also takes in the screen that is passed in here, because it needs this whole surface here. It's creating a surface this entire length and width, because of just some rec stuff and where the overlap is. Overlap mask this is a bunch of math. I'll link the Fluffy Potatoes video actually, because he does a really good job of explaining kind of, this is kind of, I think, like word for word taken from his stuff. Just because like there is kind of no other way of doing it, but this is a really good way of doing it. It's just using some math. It has to do with some rec stuff that's also in the Pygame documentation. I'll link Pygame and the Fluffy Potato and the GitHub again, all in the description. Then put that mask on the empty surface. This is just taking this mask that it's just created and then drawing it to a surface that will be used later, because of a certain function that you'll see in a little bit. Then we append that to the list of overlaps, and then we return that overlaps. Long-winded explanation, but that's it. Then we do remove pixels. Remove pixels requires a list of overlaps, and it goes for each overlap in the list of overlaps. We get all the pixels. This is using a Pygame pixel array, which if you run the game, a pixel array is every single pixel on the screen. All 1,000, all 750, so all 750,000 pixels. No wonder it was laggy. Which I do have a comparison video if you would like to see that. I actually have leftover code from some of that stuff. This is where it checks if there even is an overlap. The reason being that I did have a code that was previously here. It's no longer there. Basically what it did was it just checked through each list. It checked through each pixel array row and checked, is there even anything unique here? Right. If there wasn't anything unique, it said false, which was better than checking every single pixel. It was just checking each row, and if there wasn't anything there, then don't do it. Then return false, true otherwise. It just meant that it didn't even go through this whole loop here if there was nothing there to iterate over. It was quicker, marginally. Again, this will be linked in the description if you want to see the comparison. Yeah. But this gets to level, I did a better method, which is the indexes. It takes the rect of the explosion, and only checks over that 80 by 80 pixel area. If you do a giant explosion, it's going to be a little bit more complicated to do. Not complicated, but it's going to be a little bit harder to run. It might be a little bit more laggy just something you have to think about when doing large explosions. But Worms doesn't really have that, I don't think. Level pixels. This is all the pixels in the level. So basically all the pixels in this image here. This is every single pixel here. Just getting a pixel array of that. And then we're iterating over each of the rows. We're checking, this is checking only, you know, like pixel here to pixel here, like this little area here. It's checking only this place, this position in each of these lists. And then for each of, or it's actually checking over each of these rows here. And then we're checking which, then this is getting the column here, using that same index thing. It's not super complicated. I'm not great at explaining things. I just figured I'd put this out here because there's nothing on how to do this. And I figured, hey, if I struggled, maybe somebody else will too. This is just helpful for people who are looking for this specific thing. Yeah, so next thing. It's checking if it's not equal to 0 and if this isn't equal to 0. If both are not equal to 0, it means that there is a pixel there that is true. It means that there is something there on both ends. And if both of them have something there, then that means that we need to get rid of it. We need to get rid of that pixel. So it sets it to this, which this is black. It's fully transparent too, though. This could be any color here, but this is the pixel that's important. It needs to be, this final value needs to be set to 0 in order for it to be transparent. And then we delete the level pixels and we delete the overlap pixels. This has to do with the reason with how Pygame does pixel arrays. Pixel arrays, I don't know why exactly, they lock the sprite, so you actually can't do string.blit with that. And then this right here updates the mass of the level. This just updates the collision. You can actually see this here when I click here. You can see that this is printing out the mouse position, but if I click there again, since there is no mask here and no collision, it won't do it unless I click in an area that does have collision. But that's basically it. That's how the explosions work. A little complicated. Took me all day to figure this out, but so did the level generating, and that thing is actually pretty simple. If you want an explanation of the levels, maybe I'll do it. Just comment, I guess. I don't know. That's about it. I think that's going to be it. Again, everything in the description. I kind of yapped. This isn't the best video. But the code is on GitHub. If you want to see the code, look at the code. It might help you. There's just really nothing out there for this. So, yeah. That's about it. See ya.